Hello, everyone, and welcome back to Perceive 2021. Please give a warm welcome to our own Stanwell Yusuf, a solutions engineer for Clarifai, who will be speaking about training detector models for healthcare applications. Welcome to our stage.
Hello, everyone. My name is Stanwell Yusuf. I'm one of the solutions engineer at Clarifai. Today, we're going to look at an application of how to create an application specifically geared towards healthcare. Before I was at Clarifai, I used to be a freelance data scientist and a full-time pharmacy technician. I graduated with a bachelor's in pre-medicine, then did decide to go to med school and then moved into data science. It's a long journey, but throughout my journey, I saw the very real possibilities where AI can be applied to really aid healthcare. So we're going to look at one of those applications, and that is identifying different kinds and types of pills and tablets. Now, before we get to that, for those of you who don't know, this is the screen that we're looking at is our portal. This is a UI wrapped around our API. So Clarifai's main power rests in its API, and then this really powerful portal, where anything you can do in the API, you can do in portal. You can sign up for this by going to clarifai.com, sign up, and you'll be back here, maybe with not as many applications. The simplest thing you can do in portal is create an application, and you'll fill out these information. It's pretty descriptive. The real power will come to this base workflow, right? So base workflow are these giant AI models, which really speed up model delivery and model creation and essentially just go to market time. While I was a data scientist, if I were training a AI model from scratch, so for example, one of the models that I trained was to identify between different kinds of cars, right? The BMW, an Audi, a Mercedes, and something else. It was for a data science competition. Now, for each category, it took us about 5,000 images to get about 80% something accurate model. By using base workflows, which are these giant AI models, and using their learnings, leveraging them to create the same model by using as few as 50 images per category. Now, that's revolutionary. That's where we can use these AI models to really accelerate not just AI, but different use cases. So for our use case, we're going to look at the general detection, but there are other workflows that you can use. We're looking at a few more than you would see when you sign up, because I'm using an internal account. But for our use, the general model is a model that can recognize 11,000 unique things. And the general detection is built on top of that general model. So once you select general detection here, you'll end up in this app that looks like this. You'll have your basic information giving you what app you just created. The base workflow will be general detection. And this is where your API key would be. You can copy it and work with it and do a bunch of different things. This is essentially just an app level authentication. Before we get to the solution, we have to identify the problem. All right, so if we pull up an image right here, and look at just our general detection. So if you were saying, hey, I just want an out-of-the-box model, the problem is the general detection is not very great at identifying these images, right? So it's identifying them, maybe you'll pick them up, maybe you won't, right? So if we go back here, like it's picking it up, but it's not really very delineated. So to do that, we can actually train a custom detector and pair it with transfer learning to create a custom recognition model. So the output for that will actually look something like this, where it would tell you not only the actual, not only detect the pill, but actually show you the actual category or the label of the medicine to say. So we're going to look at how to build something like this from scratch. Before we get to that screen, we first have to kind of get comfortable with the AI, the UI here. We just saw the application details. We saw data mode. We didn't see data mode. So data mode is actually where you can see basic information like how many images you have, how many processed, on all this good stuff. Explorer is where you'll be able to see all your data in one place. It's really handy when you're creating models and debugging things and trying to make models better. Model mode is where you really get to see the power of AI, and especially Clarifai, because you have all these ready to go models. We won't be using any of these at the moment, but it's just amazing to see these models just ready to go. Then we have labeler. We will use labeler in one of our steps. But before we get to that, let's kind of walk through what we need to get back to this screen where we can actually not only find the pills, but actually classify them, like as this is being classified as lisinopril 20. So over here, I have uploaded about, I think, what, 303 or 300, yeah, 303 images. So we're going to use these images to train a custom detector that only detects one thing. That's this concept right here. And you can create a concept by creating your concept right here. So what you would do is you'll start off by unloading or essentially uploading all the images here of different shapes, different colors of tablets, and just create this concept called pill. Once your concept is created, you will then create a labeling task. A labeling task, it's just makes it really easy for you to label images. You can either do them collaboratively as a team, or you can do them, or you can have our labelers, that's Clarifai's labelers, do it for you. Now, if I were creating a task, let's just call it demo task. You can write instructions over here. Let's say write something generic to see how this functionality would work. And then you come down to task types. There are three kinds of task types. So we have concepts. A concept is when you're labeling the entire image. Bounding boxes are when you're labeling specific parts of an image or putting boxes on specific parts of an image. And masks and polygons are just bounding boxes, but with a lot of edges. For our use case, we want to put bounding boxes on tablets because we want to draw boxes around them. We will use all inputs. And like I mentioned, we created a concept called pill. So we will select this, right? And here you can either select your own labelers, or that's you collaboratively by yourself working by yourself or working with your team, or you can use Clarifai's labelers. Now, if I wanted to say add another collaborator, I could add them, like let's say I could add this one of my colleagues to work on this labeling task with me. I can ask Jeff, please help me label these images. And then you can choose these people that you want to add here. And in this case, I'm going to leave it to myself. I'm going to just use, save Jeff the burden and label these images myself. And under worker strategy, if we select more than one person, we can actually partition these images where roughly both of us can get equal amount of images, or each of us can get the entire data set, and then we can do consensus review. But since in this case, I'm just going to do it by myself, I will just assign all these inputs to me. And review strategy, you can choose manual or consensus. I'm going to leave it at none because I hope I can do this without messing it up. Right, so once your task is created under labeler, assigned to me, this is the task we just created. If you click on it, you will end up right here. This is where you can use it to label images. Like you can either click this button right here, or you can use the keyboard shortcut like #1, and then just draw this bounding box. Now these images are already labeled, so I'm not going to do it, but we will do a labeling task. This is just to set the reference for it. And this is where we added those instructions. Right, so far, just to recap, we have created an application with general detection, right? We uploaded our images right here. We then created a concept called pill. We then went to labeler. We created a task. We did the task. As a result of the task, we have 302 images labeled. They may differ. There might be more or few in your case. Now we're going to create a custom model. We go back to our model mode under create custom model. You'll see all these types of models all have great uses. The one that we are going to use is Visual Detector. Right, you give it a name. You select the concepts that you want to use. In this case, that would be pill. And pretty much everything you can leave at default, unless you're a data scientist or a machine learning expert and you want to play around with these things, and you can feel free to do though. I already have a trained deep learning model, but this is pretty much how I created it. I gave it a name. I chose my concept pill, left everything at default. And for my template, I chose Inception v4, which is a pretty well-recognized AI architecture or deep learning architecture. Just makes it easy for us to train these models. I left this at default as well, created model. And when that model was created, I had this right here. So once you have created your model, all you have to do is hit train model, and it will train the model for you. And you can also see the metrics for this model if you're interested in that sort of thing, like how is it performing over different things. So we're halfway there. So we had a problem. We tried to identify these tablets with a general detection model. It was a little bit iffy. We weren't too happy with the outputs. So what we did was we created an application with general detection as the base workflow. We then uploaded our data set into that app using our API key or our personal access token, using the extensive documentation that we have on our docs.clarifai.com. And once our images were all uploaded, we created a concept called pill. We then went to labeler, created a task. Either we assigned it to ourselves and our team, or we had Clarifai label those tasks for us. We then went into that created task. We labeled all the images. Once the images were labeled, we went to model mode. We did create custom model. We scrolled all the way down to Visual Detector, filled out the name, chose the concept that we want to train on, pretty much left everything at default, shows our architecture, left that to default as well, created the model, and then trained the model. So now we have a detector. So earlier, general detection was having problems detecting it or detecting this tablet right here. Now we have a trained model that can actually detect these things. So we're halfway there. Now we detect these tablets. What we want to do now is actually classify them, like what kind of tablet it is, what medicine it is, which is something we will do next. So what I have done here is I have actually copied this app over. So what you can do is if you go back here, so it was this one right here. I just created a copy, and as a result of it, we're right here. Same everything, general detection based workflow. I deleted all the images that were in here because we no longer need them. If you feel the need to keep them, feel free to do so. It doesn't really add anything here. But now if you see right here and pay attention, there are kind of three kind of tablets, capsules, medicines here. You have like these yellow ones, these pinkish ones, and these white capsules or tablets, right? So these yellow ones are amoxicillin 500s, an antibiotic, lisinopril 20, a blood pressure medication, and these are cetirizines 10 milligrams. This is an allergy medication. So we want to use these to create a classifier that, using the detection, this model that we have trained to detect capsules, detect tablets, actually not only just detect them, but tell us which of these capsules they are, which of these tablets they are. And that is what we will do next. Now, I did something interesting here. Not only did so if you look into any of these images, you will see they don't have any annotations. So they don't have any labels attached. But I did add metadata here. Now, what is the use of metadata? Metadata is used to filter data within an app. You can use it to do great things like visual search, find similar images, and then filter them on metadata. But in this case, we're going to use our metadata for labeling. And the reason for that is because, let's say you're creating the same kind of model. So you are all a bunch of data scientists, like you have 10 data scientists working on this problem. but you're pharmacists. You don't know which capsule is what, you don't know which tablet is what, and the last thing you want to do is label the wrong capsules, because that's just terrible data. What you can do, and in this situation, let's assume that you have labeled data sets, so you know that this medicine is amoxicillin. So what you do is actually you add this as metadata. And in this label, when I'm talking about it, I'm saying like you actually have this as, this is amoxicillin, but you don't have the bounding boxes for this. Now, if you had the bounding boxes, the game's over. We can just upload the bounding boxes right through the API. But in this situation, we have images that have been labeled, like somebody has taken an image and given the name to that image amoxicillin 500. That's the extent of it. So I took that name of the image as amoxicillin 500 and added it as metadata. So we're going to create a labeling task now. So let's just create concepts, amoxicillin 500. Then there is lisinopril and cetirizine 10. All right, so we have, so just to recap, we copied, so after we trained our detector, we copied this app over. And in that app, we got rid of all this old data that we see in here, because this was no longer relevant to us. We wanted to train a detector with it, and we did. In this application, it serves us no purpose, right? And so we added more data here, fewer images, like 5 images per category, even that, if that. And then we added these images with metadata. And then we created these 3 custom concepts because there are the 3 tablets here. Yeah, let me just make sure this is working fine, because sometimes when we copy over applications, we want to make sure that the most recent version is the trained version. So this yellow pill that you see next to the model shouldn't be there, just means that the model is not active. We just have to make it active. That's not a problem. There you go, it's active. So where were we? We uploaded images right here with metadata, and now we're going to create a task. Same thing that we just did. Just create a task, let's say, label these 3 tablets. Bounding boxes. Going to use all the inputs that we have, that are about 12 or so of the images. And we're going to choose these 3 concepts. So as amoxicillin, cetirizine, lisinopril. I'm going to once again assign this labeling task to myself. I'm going to assign all the images to myself. And I'm going to set the review strategy to none, hoping that I don't make any mistakes. All right, so once the task is created, we come back to our labeler, assigned to me, and we enter this task. Now, why did we add this metadata? Let's assume I'm just some person doing these labeling tasks. I don't have any medical background. How do I label them? And that's where metadata comes in, right? So I have uploaded this. Oh, looks like this metadata got messed up. Anyways, that's fine. That just happens sometimes. So we have images here with, this is an amoxicillin 500. As we saw earlier, this is, you can either toggle this button right here, or you can use the keyboard shortcut. Keyboard shortcut is easier for me, so I'll just do number 1 and do a bad job of labeling, just so we can get through this fast. So this is being labeled as lisinopril. That's another 2 lisinopril 20s. And then we have some amoxicillin 500s. It's just labeled some. And when you're adding data, you want to get as diverse data set as you can. Then that by diverse, I mean different shots, different lightings, different situations that you would in real life find these tablets in. So in a pharmacy, in a hospital, like just take different images, just take some of your team members and just send them to your pharmacy and you're in your hospital where you are, and then just have them take the images. That is a better data set than anything you will find. All right, so let's, oh, nope. I labeled the wrong thing. This is not physonopil, this is cetirizine, but we can just erase all those labels just like that. So we have cetirizines, just label them some, just for the purposes of showing. All right, so we have a bunch of cetirizines. Let's label a few more. Number 2, just this. Okay, all right, that's good enough. Label some more amoxicillins. More lisinoprils. All right, so we just labeled 11 images. And if we go in now to the annotations, we should be able to see these images labeled. And we are almost there, we're like 90% there. So just to recap, we have trained a custom detector. We then added some images of specific tablets and capsules. We then labeled those capsules and tablets. Now we have labeled data for them, right? And now we're going to create a model. This time we're not going to create a visual detector. We're going to create a context-based classifier. A context-based classifier is a transfer learn model, which is built on top of our base model, which is our general detection model in this case. So let's say, give it a name, pill detector. Classification, this is not a detector. We're going to select our 3 tablets that we just labeled. Now, the only thing to notice here is this one right here. Concepts mutually exclusive. There might be some cases where you know that an image is going to contain either amoxicillin or cetirizine. And if that model is only going to see those situations, then you can set it to true, where you're saying, hey, model, I want you to know that these 3 categories or these 3 concepts will never be together in one image or in one input or in one video frame, whatever. In that case, you'll set it to true. But in this case, I'm assuming that this is a real life situation where they're like loose tablets or whatever, and we're trying to identify them. So in this case, they might be in the same input. So I'm going to leave it to false. Everything else stays on default value. And then we just train this model. All right, model is trained and ready. We have now, we did a bunch of stuff. Let's just recap just to make sure we're on the same page. We started out with an application that had these unlabeled images. We dumped them all into an application. We labeled all of them with this one concept using bounding boxes. We then trained a custom visual detector, which we can do by going to model mode, create custom model. At the very end, we find a visual detector. Now, once the visual detector was trained, we copied this application. And then we got rid of all of this old data, because in this new application, this old data was no longer useful to us. We had the detector we wanted. Now we were going to train a custom classification model for specific things based on top of that detector. So we did that. We labeled those images. We created a custom classification model. Now comes the final step, and that is creating a workflow. A workflow is where you get to put together and chain together different models and get the output you want. So just go to create workflow. You can either see models under your user or under Clarifai. Under Clarifai, you'll see all these models. So just before we start on that, let's kind of walk through what we would need to do. So first of all, let's just think of it like in our minds. We want, first of all, to detect a tablet in an image. So we need a detector. We already trained one, so that's our detector. Then we want to really focus, like hyper focus on that area where we detected it. So we need some kind of cropping mechanism. We want to crop out all, like a small section from that image. So we need a cropper. And then we need a classifier. So we know that we need at least 3 models. So let's get to work on that. If I switch back to my user, this is the visual detector that I just trained. So I'll add this, right? Now we said we need some kind of, so this model is going to detect capsules, tablets, whatever. Now we want to crop those regions because we don't care about the entire image, we care about the specific parts in an image. I'll switch back to user Clarify. And I'll do filter output by image. This would bring us to these models right here, margin 100, 150, 110. These are image crop models, which are going to do exactly what we just described. We have detected things. Now we want to crop them. So I just use the 100 by default. So I'm just going to keep it at that. There's no reason why I do it. It's just something by the force of habit. So we have detected something. We have cropped something. Now we have our custom model that we just trained. That is a custom classification. That's this one, perceive pill classification. But if you look at the input type, it doesn't take an input as an image. It takes embeddings as an input. Now, if I add this model right here, the workflow builder will get very mad at me. It'll say you're giving me wrong inputs, but we can fix that as well. We go back to our user Clarify and we filter by output embeddings. So this is a general embedder, which is used in our general model, general detection models. So we're going to select this embedder and add it at the bottom. And then we get to add our custom model that we just built. Right here, perceive pill classification. All right. So we're just one step away from fixing this problem. So let's walk through what's going on here. An image will come in, or an input will come in. Something could be an image, a video frame, whatever. So an image, that input will come in. So this custom detector that we trained in this application right here, this will detect the capsules, the tablets, what have you. Then this margin model needs to crop out those detections so that we are hyper-focusing on things we care about. Then for those hyper-focused crops, we need to create embeddings. And that is what we would do is we'll take the output of the cropper and feed it to the embedder. So for each of the crops, we will have embeddings. And finally, things will get fed to our custom classification model. So let's give it a name. Let's say perceive pill classification. Oh, it's going to get too long. Let's say pill workflow. All right. Let's just double check our work. We have detection, we have crops, we have embedders, and we have custom classification. Fingers crossed. There we go. Workflow created. Now, we don't want to test just on the images that are already labeled. That's kind of cheating. So let's upload some images that the model hasn't seen. That is these 3 images. Right, so these top 3 images, if you go into annotations, it doesn't have any annotations attached to it. But if, let's close down annotations. If, and the general detection once again is doing poorly on this, we switch to our workflow we just created. And there you go. We can adjust all this, and we have not only are we detecting pills, but we can also tell this is a lisinopril pill. Same thing here, not only are we detecting pills, we can also tell, let's just put this down, we can detect and tell that this is amoxicillin right here. And there we go. Let's drop down the classification threshold here. And there we go. And oh, this is something to know. We can adjust the threshold based on how, like, we want to say, okay, give me only things you're like 90% sure here. So this would only return things that are 90% sure. So it's detecting classification. It's 100% sure this is a pill. It is not as sure that this is a amoxicillin. Now, why is that? It's because there's not that many images to train with here. I mean, we have about, amoxicillin has 11 and then 14 for cetirizine, 9 for lisinopril. While so generally, as a rule of thumb, we should have at least 50 images per category, and that's when we will, start seeing really good results. So, just a final recap. We had a problem. We wanted to detect these capsules or these tablets. Our general detector wasn't doing a great job. So what we did was we uploaded images. different shapes, different kinds of tablets. We then labeled them with this concept, pill, by using our labeler. We then created a custom visual detector called pill detector inception. Once that model was trained after being created, we copied this entire application into a new one, got rid of all this old data that we don't need in this new application. And then we uploaded about 20 or so images of different capsules and created 3 concepts. Each capsule, the amoxicillin 50, cetirizine 10, lisinopril 9, seropril 20. Labeled those things, labeled those image tablets as such, created a custom classification model or a context-based classifier, and then put these 2 models in a workflow with other 2 more models. And that is what we have here, is like we have a detector, a cropper, an embedder, and a classification. So in about half an hour, we were able to train a detector from scratch, put it in a classification model, and solve a real life problem in healthcare. And that's my demo. Hope you guys enjoyed it.
Thank you so much, Sanwell. It was a pleasure. A big round of applause from our virtual audience. We will see you at our next session.